And welcome back to Midterm Review. This is video number 3, pages 8 through 11, as promised. You may have thought we weren't going to come through, but we did. And
As always.
Dr. Conklin will start you off with number 37.
Awesome. So when we start these, we want to remember the 5 ways to show triangles are congruent. And one of the first ways is side, angle, side. So you want to mark the pictures up. We have an angle already. We have a side matching up. So we want to figure out how we can make this side, angle, side. So I'm going to just color in this angle here. If it's side, angle, side, we want to make sure that our congruent side is touching that pink angle. So I'm going to highlight GA and LO, and those are the only 2 that are going to make this side, angle, side. You can, right off the bat, get rid of the angles because that wouldn't be side, angle, side since we already have a side. If we look at choice 38, same idea. We're going to mark it. Now, any time you have parallel lines and a picture having to do with triangles, you always want to look for alternate interior angles. So I'm going to mark these up. Since we have parallel lines, we can say alternate interior angles are congruent. We also have a line touching, which is reflexive property. And then they also told us that ABC, which is up here, is congruent to ADC, or CDA, which is over here. So here's the trick. If we look at this angle, or I'm sorry, this side here, is this side touching all of the congruent angles? And if you notice, it's not. So that's the difference between having angle, side, angle, and angle, angle, side. If this side in the middle is touching both the pairs of angles, you use angle, side, angle. But since this side here is not touching all the congruent angles, we're going to have to use angle, angle, side, or choice A. Similar here, we have our friend, the reflexive property. And then we're told these 2 angles are congruent to each other. And this is a bisector, so a bisector cuts an angle in half. So we also know these 2 angles are congruent. Again, since this side is not touching every congruent angle, we're going to go for choice D, angle, angle, side. And then last but not least, which statement must be true? If you look at this, we have a side here, an angle, an angle, an angle, and another angle. So we could use angle, side, angle to say these are congruent. So this question is really just asking us to pair up which sides match up. And the only 2 sides that are going to pair up are going to be AD and CD.
Okay, we are now on page 9, number 41. They give us this angle and this side being congruent to this angle and this side. And there's nothing else given, but we all know our friend vertical angle here is always there. You have to find that on your own. So if that's true, then we have angle, side, angle. In 42, it tells us that the triangles are congruent to each other, which also means that we have corresponding parts that are matched up, corresponding angles, corresponding sides. Which statement is not always true? If you go through these choices, choice D, angle ACE, and angle DBE would not necessarily be the same, because if you mapped this one onto this one, it would go up into that corner. And they say not always because it's possible if they were isosceles and it was a reflection, they could be, but it could also be a rotation. So D is not always true. And number 43, the question says, based on what's given, which cannot be proven congruent? I'm going to start with angle, side, angle. That works. I'm going to start with a right angle and hypotenuse leg. That works. I'm going to start with angle, angle, side. That seems to work. But here I have angle, side, side. And if I spell that out, no, I better not do that.
Swear,
Whoa,
Mr. Fields.
whoa,
No.
whoa, whoa. That is not a postulate, even though some of you still write it down as answers on your quizzes. So because ASS is not a postulate, that is the one that doesn't work. And in 44, it tells us, it made us draw the triangle first. And it says that angle RST is 46, so I labeled that at the top. It also tells us that RS and ST are congruent, so I labeled that here, which makes this an isosceles triangle with the vertex angle 46. If a triangle adds up to 180, which we know it does, and we take away 46, that leaves us as 134. But we have to split that 134 evenly into those two base angles, so we divide it by 2, and each of those angles is 67 degrees.
We're back with page 10. On number 45, we have a 40-degree angle here. Since these two sides are congruent, we know base angles are congruent. We can add 40 and 40 to get 80, and then we're going to do 180 minus 80, and that gives us this top angle. The vertex angle is 100 degrees, choice D. So we already mentioned this in our previous video, but equilateral triangles, all the angles are congruent and they're each 60 degrees, so we're going to use that. And then if we look here, we have supplementary angles for 120 degrees. We're trying to find angle C, so one strategy is to just put a little star where you're working towards. And then if we look at this, we're also told DB is congruent to BC, so we have an isosceles triangle in here as well. Oops. So we're going to do what Mr. Fields just explained. I'm going to take 180 minus 120. That gives me 60. Since we're splitting that 60 into two angles, that's going to give us angle C is 30 degrees. Number 47, this is a great open response question. It says determine whether GHK is isosceles triangle. So what we're looking for is if we have two congruent angles. And then it says justify your answer. So that means showing some work. So we're going to start. We have 28 degrees in one corner and 70 degrees. And we want to start by using the 7-degree angle, as we've described before, to find these two angles, or 55 and 55. And then I already drew in for us the supplementary angle. We know we have 125 here. So we need to find one more angle. And we're going to do that because if we look at the big triangle, we see we already have one angle of 28, one of 70. If we add that up, we'll find that the big angle has to be, 28 and 70 would give us 98. And then we have 55. That's 153. So this little guy has to be 27 degrees. So if we compare this angle here with this angle here, they are not congruent. So that means we do not have an isosceles triangle. And then last but not, two last but not least. This is the same idea again, number 48. So our answer choice is going to be A, 27 degrees for the measure of angle N. And then if we look at choice 49, you have three angles. All three angles should add up to 180. So I'm going to add them all up, set them equal to 180, solve for x, and get x is 29, choice A.
29 is my favorite number.
Yay!
Great. All right, so number 50 is multiple steps to this guy. So it wants you to find angle JSM, which is this blue angle. Thank you. My intro music came in just a little bit late there. But we're looking for that blue sliver of an angle in this weird triangle up here. So we have to work our way over toward it. First thing I'm going to do is find the supplement to 59. And I did that right over here on the left. So it's on a straight line. Its supplementary angle would be 121. Then, if you zoom out a little bit, you see this giant pink triangle. And you know two of the three angles in it. You know 90, you know 48, and you're looking for this angle up here. So 90 and 48 is 138. Take that away from 180, and you have that angle becoming 42. Now if you look at this yellow triangle, you know two angles in it, 42 and 121, which leaves you with 17 in the corner. My music was right on cue that time for number 51. Again, as we talked about earlier, three angles of a triangle all add up to 180. So the first thing I'm going to do is set up that equation right there. 3x plus 1, 4x minus 17, and 5x minus 20 equal 180. What that's going to do is get my x value for me. So you can see I combine like terms, isolate for x, and x is 18. But it didn't ask us to find x. It asked us to go several more steps past that and asked us to find what the type of triangle ABC is. We think this is a very, very unfair question
Boo.
for multiple choice because you can't get any partial credit for it. You're either right or you're wrong, even if you do most of the work right. So if you then take this 18 and plug it into 3x plus 1, plug it into 4x minus 17, and 5x minus 20, you're going to find out that your three angles are 55, 55, and 70. What type of triangle has a pair of equal angles, the 55s? That would be isosceles. I'm saying
right.
that wrong.
No, that was right.
Is it close?
Right.
Is it close, right? Isosceles. Okay. Thanks.
All right, this is Dr. Conklin back with number 52. We're going to finish up this video. My fire.
Oh, good
Sorry,
Lord.
I know. This one's easy peasy lemon squeezy. 70 plus 50 is always going to equal the alternate exterior angle, which they're asking for here. So all we have to do is add up the 70 and the 50, and that's going to give us choice B, an answer of 120. And then if we look at 53, this is another exterior angle question. I put a little star here in the angle we're trying to find, but we got to work over to that. So first we're going to use supplementary angles. I'm going to add up 125, or not add up, I'm going to take 180 minus 125, and that gives me this angle of 55. And then using exterior angle theorem, I'm going to take 60 and 55. If you add those up, you're going to get choice B of 115 degrees.
And that is the end of video number 3. Join us tomorrow for the final video, which is pages 12 through the end, which includes a very important short answer section where you can get a lot of partial credit, and it will mirror that of the midterm. Good luck.